Have you ever wondered why you can remember a really stressful moment with like perfect photographic detail, but you have no idea what you had for lunch yesterday? Well, today we're going to dig into the science that explains that exact feeling. And then we're going to jump into a future that is coming way faster than you think. A future where we might actually be able to decode our own memories. All right, let's get into it.
You know, this isn't just some weird quirk of our brains. It's actually a window into how we prioritize what's important. You can probably remember the sights, sounds, maybe even the smells of a scary event from years ago, right? But the details of a normal Tuesday? Poof, they're just gone. Well, it turns out the answer lies in a really powerful stress hormone that basically acts like a supercharged save button for your brain. And what's so cool is that scientists are now able to pinpoint the exact chemical reactions that create these super memories. They're literally watching the moment a fleeting experience gets locked into your brain for good, and how the chemistry of stress is the key that turns that lock. And it all comes down to a process called memory consolidation. The best way to think about it is like hitting save on a computer file. It's that biological step where your brain takes a new, kind of shaky experience and files it away properly on its long-term hard drive. So the big question for researchers was, does a stress hormone help or actually hurt that critical saving process?
So to figure this out, researchers at Johns Hopkins set up this really clever experiment. First, they had people study a bunch of images of everyday objects. Then, right after that, they put one group through a standardized and, let me tell you, pretty intense social stress test. We're talking public speaking, mental math, the works. A whole day later, they brought everybody back in to see what they actually remembered.
But here's the really brilliant part. The test wasn't just, hey, did you see a backpack? It was about a much finer skill called pattern separation, which is your brain's ability to tell the difference between two things that are almost identical. So could they spot that this new backpack was a slightly different color, or maybe had one less zipper than the one they saw yesterday? That's what a really detailed memory is all about.
So first things first, did the stress test actually stress people out? Oh yeah, this chart shows it loud and clear. Just look at the bar on the right, that's the stress group. They had a huge spike in cortisol, which is the body's main stress hormone, right after the test. Meanwhile, the control group on the left, totally level. So the biological stage was set perfectly.
Okay, so we know the stress response was triggered. Now for the million-dollar question. What did all that extra cortisol actually do to their memories? Well, as it turns out, when it comes to stress and memory, timing is absolutely everything.
And here is the single most important finding. When the stress happened right after learning, during that critical saving or consolidation phase, it massively boosted their ability to remember fine details. But in another experiment, when they stressed people out right before the memory test, during the opening a file or retrieval phase, it didn't really do anything. The magic happens when you save the memory, not when you recall it.
And the results were seriously dramatic. The stressed group was way better at spotting those tricky lure items. They correctly flagged them as just similar to the original 47% of the time. Now, compare that to the non-stressed group. They only caught the difference less than 33% of the time. That's not a small improvement. That's a huge leap in memory precision, all thanks to that jolt of cortisol.
And what's even cooler is that there was a direct link. The more an individual's cortisol levels spiked, the better their detailed memory was a day later. This points to this powerful evolutionary advantage, right? It's like our brains are hardwired by stress to take a super detailed snapshot of a potentially dangerous or important situation, which could help us survive something similar in the future.
So we've seen how our own internal chemistry can literally enhance the way we save memories. But what if we could jump from chemistry to computer code? What if we could actually read the content of a memory straight from the brain's electrical signals? Well, that question takes us into the incredible and, yes, slightly sci-fi world of neural decoding.
In this just stunningly ambitious study, researchers used a consumer-grade EEG headset. One of those things that just rests on your scalp and measures your brain's electrical activity. Totally non-invasive. They fed those signals to an AI model with one goal. Could it figure out the specific, unique concept a person was recalling from their memory?
Now, to be clear, the AI isn't reading words out of your head. Instead, it's learning to recognize the unique pattern of brainwaves, the distinct electrical signature that your brain makes when you think about one specific thing. So you can see here, the brain activity for thinking about Joan Didion all clustered together, and it's totally separate from the cluster for the Trojan horse. The AI is basically learning the unique fingerprint for each individual thought.
So how well did it actually work?
Well, after training the AI on a person's thought fingerprints for one set of things, the researchers tested it on a totally new set the AI had never ever seen before. And honestly, the results are the definition of a wow moment. The system correctly identified the exact concept the person was thinking about over 78% of the time. Now, let's put that in perspective. It was picking from a list of 25 different options. If you were just randomly guessing, you'd be right only 4% of the time. This isn't just a little bit better, this is a whole different ballgame for decoding brain activity.
And it gets even more impressive when you look at the top 3 accuracy. The correct concept was in the AI's top 3 guesses a staggering 94.4% of the time. So that means even when it didn't get it right on the very first try, it was almost always hovering right around the correct thought. The signal it's picking up is just that clear.
So, okay, this stuff is really cool in a lab, but what does it actually mean for us in the real world? Well, this kind of research is opening the door to applications that could totally change how we interact with information, and even more important, how we understand diseases of the mind. I mean, we are talking about a neural search engine. Just take a second and actually imagine that. Finding a document or an old photo or some file on your computer, not by typing in keywords, but just by thinking about it. That's the future these researchers are actually building. And the applications beyond that are just profound. Think about the medical potential here. If a person's unique thought fingerprint for a memory starts to change or get fuzzier over time, that could be a powerful, non-invasive early warning for things like Alzheimer's. Or it could be a way to objectively track how someone is recovering from a brain injury. From understanding how a spike of cortisol can physically sharpen a memory, to building tools that can literally read those memories back to us, we are without a doubt entering a brand new era in understanding the brain. We're starting to read the language of the brain itself. So I'll leave you with this to think about. If you could search your memories like the internet, what's the very first thing you would look for?